Thank you. Jed's probably like my favorite person in the whole world, so that was nice. Anyways, this looks like it works. Unicode, poop. There's a HTML entity for that as well. Just good info to have. I think that's the last actual poop I have in here, so hopefully that helps settle your stomachs a bit. Let's get going if we can. There we go. So I had a friend say this to me once. I don't want all those fancy features. I just want a program that eats Sass and poops CSS. And that's really the thing that the pooping is about. And I'm going to go ahead and extend the metaphor for you into the CSS preprocessor digestive tract. And hopefully that won't get too boring. But I'll try to stick to mostly CSS. So we often have information like this. This is a very small style sheet. We have some variables. Some are pixels, some are colors, and we mix them in, and we run functions on them. It's nice. So how do we process that? What happens whenever we want CSS out the other end? So how does eating this make Sass poop this? So preprocessors as they relate to the digestive system. Eating's probably standard in. I'd say chewing is most like lexing. I'll talk about what a lexer is. But that kind of breaks up the input into more easily digestible pieces. Stomachs are an important part of actual digestion systems, so I couldn't really leave them out. But they don't actually, the metaphor is very broken. So I just added them in here as some sort of data store that you're using, because that's really all it's doing. Maybe additional lexing. So your small intestines are kind of like the parser step. So the parser step is taking out the pieces that you need and putting them in the right places. So this would like be actually getting nutrients and moving it to nice parts of your body. Breaking things down would not be part of that, even though that's something that the small intestines do, so just ignore that. Large intestines are similar. We'll call that the compiler. It really gets it ready for output. That's where I'm just going to say output, but I think you know. And you all know what standard out is, and so we're good there. And I'm going to talk a little bit about hacking this system, and so I just had to have the metaphor for that. So one way you could hack your digestive tract is like lap band surgery, where they like make your stomach smaller, and then you have less memory, and so maybe your output is slower, or you lose weight, or one of the two. So parsing and compiling is really what I'd like to talk to you about, rather than the digestive tract. So parsing is actually pretty easy. On a high level, it uses syntax rules of the language, and it figures out what every little part of a string is, and it breaks them down into tokens. So in this case, you have the $, which in Sass means that it's the start of a variable. And then you have the name of the variable, which is blue in this case. You have the equality operator. CSS uses the colon to mean equals. And so that's what Sass uses. And then you have the value. It could be any arbitrary string usually. There are rules about what can go there. You can't have Unicode characters, though like if it was in a URL or something, it might work. Probably just about anything there, except for a semicolon. And then you have a rule delimiter to say, hey, this is the end of the rule. And so that's pretty easy. You might be able to write a regex to go through and break apart those things. You're really looking for 3 things in that case, and filling in the gaps. You see the $sign is a variable, and then you fill in the gaps until you get to a colon, and then you fill in the gaps, and you get to a semicolon. And so that's really at the very base of how you set a variable, how a computer breaks that stuff down. More specifically, it goes through every single character, and it says, is this part of anything that I might know about? And it has a few options. And if there's only one option, then it says, oh, this must be the $sign to mean a variable. But if 2 things could start with a $sign, it might look ahead and do other things. There's lots of ways to write parsers that I don't even know about. Here is my most simple example of how you might write this parser in JavaScript, which Sass is not written in. The most non-congruent part of my talk is that all of my examples are in Sass and all of my code is in JavaScript. So you'll just have to deal with that mental trust point. Anyways, we essentially just loop through a string. We get a string in as CSS. It's just text. You have characters in there. And in this case, we're just saying if we loop through and the character is a semicolon, we know there's a semicolon. And so we have a list of tokens, and then we push the semicolon token. In this case, it's just the string semicolon, which probably might be OK for semicolon, but you'd probably need more info, like the variable is this type of variable, all kinds of stuff. This is a very simplified example. So you'd want one of those things where you're noticing a semicolon for every possible thing in the language, unless it's dynamic, and then you use other techniques for those. More realistically, you probably write a parser generator. Some people might disagree with me on this, but most of the time, when you need a quick parser for something, you can actually use something like peg. That's a parser expression grammar generator. And you can generate a parser based on expressions. And so you say that a class is actually just a dot followed by an identifier. And then you kind of say, like, whenever I build this up, say an element is just an identifier or the asterisk for everything. And identifiers can be anything with dashes or numbers or characters and all kinds of weird stuff. You don't necessarily have to understand the syntax or more or less anything here, other than that you can kind of build up a language, and then someone will actually just generate a very fast parser for you, and you don't have to worry about this type of stuff. Unless you want to make it very, very fast, in which case you do this by hand in C, which libsass, things like that. That's how those work. So when you're done, you need to represent the code as data. It comes in as text. It comes in as an array of characters. So this is text, and you eventually, after lexing, have this. You have the variable starting, you have the string, you know the value of the string, you know that the next thing is equals, and that the value of the everything. So you have that. And you want to actually add structure. So you take the variable set, and you know that this needs to end with the semicolon. You say, actually, the way setting variables works is it has two sides. And so you're going to build an arbitrary object that says the left side is the variable name, and it's blue, and the right side is the value, and it's 3BBFCE. I don't know where that value. Jed had all the switching names this morning. Pro tip, that was a good move. Styles have structure, so even further, you might have the style sheet object that wraps that whole thing. So if your whole style sheet was just one variable declaration, it might look kind of like this. You'd have an object that said, my type is a style sheet, and in it has declarations. And the first one is a variable that's set in a certain way. And the second one is a declaration. The selector is the stuff class inside p tags, and the rules are left color value, the color of FFF. So we're just saying stuff, p stuff has the color of white, and that actually might look more like this in Sass. So you have bodies and you have a tags, and they're nested inside. The hover states are nested inside. So you actually have what ends up looking like this whenever you actually break it down. I can make this smaller for you. Maybe I can't. There we go. Closer. So we end up with a hierarchy. We have a style sheet, and we know that we have a body rule, and we have an A rule, and inside of those we have rules, and inside of those we have rules. And with Sass, you can nest infinitely. I think Nicole once said that you should follow the inception rule and never go more than 4 levels deep, which I like. That is good. But technically, you have the ability to go as deep as you'd like. In normal CSS, you can only have 1 level, but it's still a tree. It's just not that tall of one. Anyways, this is an abstract syntax tree. That's what I've been describing. It's confusing because there are almost no rules. If anyone asks, an abstract syntax tree is just a list of things that contain one thing or other lists of things. I like to call them arbitrary syntax trees. They almost don't mean anything. So they've got such a cool name that you want to derive more value out of that name. But really, all it is a representation of the meaning of your syntax in a structure. So in the case of CSS, we don't want just there was a variable, then this, and then a semicolon, and then this. Like, there's no actual structure that means anything. We want to be able to say that this is a group that contains rules that contain groups that contain rules. And we know that the things inside of a group apply to only its outer selectors. So what can we do with it? Lots of stuff, and that's why it's fun. So I'll go into what we can do with it in a second, but the compilation step is the first thing you would normally do with it, compile it to CSS. So reduction is the first step whenever you're dealing with something like compiling Sass into CSS. You have SCSS, which we've been using here, and it's kind of like a superset of CSS. Most of the things are very similar. And so we want to take the data from the SCSS that looks kind of like this. We have a variable that we're setting to blue. So we're saying blue is that 3BB number. And then we have a rule that uses the variable. And that's not valid CSS, at least until CSS level 4. Not CSS 4, CSS unversioned level 4. Totally different, guys. Come on. So this is not valid CSS. We couldn't compile this. We couldn't turn this back into a string and have this actually work in any browser. What we want to do is reduce the variables away. So in this case, we'd say find any place that has the value where the type is a variable and the name is blue. And that'd be pretty easy. And then just replace it with the value of the blue variable. And you might be able to do that in your head very easily. It's somewhat complicated in code, but we won't actually have to do that. And so you end up with this. And this ends up being actually a completely valid CSS syntax tree. We just have a rule, and the name is the color, and the value is a legit color. And we can just compile that single rule into CSS, and there's no problem. And that's valid, 100% valid CSS. You could even use the Sass Lexer backwards. Not that Lexers work that way, but because SCSS works that way, you could turn it back into what the SCSS representation of this would be, and it would be completely valid CSS in this case. And what you would do is just do that on the most specific node, and then you'd go up, and then you do that on those nodes, and then you go up, and you go up, and you compile. So I lost too much recursion, everybody's friend. So your reduction comes from this, and you're able to output this. And you do that recursively, leaves to trunk. And I say leaves to trunk because there's a split somewhere in the middle of the room of people who say that that's up the tree, and there are people who say that that's down the tree. And I think it's probably down the tree, but because you're going leaves to trunk. But whenever you represent a syntax tree, you actually draw it upside down. And so it's actually more like stalactites or something. And we should just change abstract syntax stalactites from now on, if you would. Or arbitrary syntax stalactites would work for me. Anyways. So we take something that looks like this, we put it into structured data. You don't actually have to read that. But this is, some arbitrary way of saying there are declarations with rules inside of them, and we know what they all mean, and it's just big and ugly. And we reduce that to something that is valid for CSS, and you don't have to know what's going on here, but we no longer have variables in there. We no longer have nested structures. It's all a valid tree, and then we're able to just turn that back into text again. So it takes one type of text, converts it into a known but arbitrary data format, and then it converts that data into a different but arbitrary and known data format, and it converts that back to text. So that was like a very long, drawn-out way of saying that it takes text, turns it into data, fiddles with it, and then turns it back into text. So there's the very sophisticated graph on seeing that. More apropos to the title, We have our digestion system. I threw in some buzzwords. Streams, I don't know what that would be. I guess you pipe saliva into a standard in. Anyways, this is really just a silly metaphor. The only hard part is actually there in the middle. We're pretty good at parsing. You can use parser expression generators. We're pretty good at even knowing how to define languages as context-free grammars or regular languages. There's whole automata theory on all that stuff. So we're pretty good at taking text and turning it into data. And we're pretty good at turning data and putting it into text is just the reverse. So the magic of SAS actually, other than some speed things, lives in the data 1 to data 2 conversion. And it's interesting how they do some of that stuff, but it's not really the point. So I want to teach you what you can do with it. Data 1 can be interesting. Just reading the data can be pretty eye-opening. So data 1 would be that data that once we turned it into a structure that represented our SAS, what information could we get from it? We could count how often we use variables, or we could change them before they ever get used. We could move rules around. We could reduce things. We could lint. We could change the output formats. We could output to multiple formats. There's a lot of work you can do by having your styles as data. And it's super cool to me. So as long as your data is valid at all points, it doesn't matter. You can send it back in. So you could take in text, turn it into data, throw that data away, create your own whole new data, and then compile that to CSS, and that's fine. It just wouldn't have any bearing on what you put in. And that's an OK thing, I guess, sometimes. So I wrote this very important modifier of rules. And so you would pass this in as a filter to your AST. So your data comes in, and what it does is it says, find me all the rules. So you don't want to find the selectors. You don't want to find variable names. All you want to say is anywhere where there's a rule that has a value, let's check that out. So we'll say if it has a value, say the value plus important. So we save every value as important and then write it back to the tree and then recursively do that. So we call ourselves over and over. So we go all the way down and hit every single rule in our entire CSS file and then just return all that. And then we compile that, and now every single one of our rules is important in the output, and you didn't have to write those by hand. So this will save you a lot of time doing what you're already going to do anyways, which was probably just add important to everything. Luckily, we can do the reverse, the undo intern work AST modification tool. So we go through every single node. We find if it's a rule. We say, if it matches important, return null. So delete the rule entirely. Don't turn it unimportant. Just say, if this is important, then it should die forever, which is another valid opinion to have. Outputs may vary. And that type of logic works in every preprocessor. Obviously, that code will not work in every preprocessor. Everyone has different ways of storing nodes and values and things like that. Rework is one by TJ, Vision Media, who has 500 or 600 modules on GitHub. But it is made specifically for AST hacking. He actually ships it with no features. It literally just takes stuff in, turns it to data, and then turns that data back into CSS. And then it's up to you to stick stuff in the middle. So you might be familiar with the term middleware. So you write a bunch of little middleware pieces that change nodes around. And you say, if I want to add variables, I just add one little piece. This is variables. And that's the only thing I want to use in my preprocessor. So I'm not going to add in nesting, and I'm not going to add in gradients or variable what are the vendor prefixes, all that kind of stuff. You don't need them, so don't add them in. Or you could do totally custom stuff. So a little more real world problem that I actually ran into in my day-to-day work is that compilation of styles is fast. You can take a SAS style sheet or stylus in the case that I originally had. And you can compile styles pretty quickly. So it's rarely the bottleneck in anyone's build step. They can get slow. Some people will move to libsass for that kind of thing. The asterisk there is until you want to hook it up to a change event. So if you hooked up the color picker to a change event and said, on change, 60 times a second or whatever that can do, go back to the server, recompile all my styles with the new value, and set this variable just to this new value that I have on the change thing, and then send all that back up, delete all the styles, and put all the new ones in, that would never work. And luckily, now that you know about ASTs, you could fix that problem. So in something like a theme builder, you would want a size slider or a color picker to do all this stuff in real time. So the only way we can avoid the time it takes to recompile is to not recompile. And luckily, we can capture that data at the data level and use that to our advantage and still only ever write the Sass or the stylus or the rework that we want to write. So we'll open up a demo for you. This is a fun little page. It's got a pun for Jed, leaf, and tree, just to point that out for everyone. Thank you. So what we have here is a pretty simple page. I put it together. It's an Express app. If you saw the first slide, I had a link to it, but you can get it. It'll be on the last slide too. And you can run it from GitHub. So what we have first is I'll pull up a my CSS. My CSS is my personal compiler for CSS. All I did was add variables. I used Rework to do this. And so I add this one little guy here that says var, and then I pass it a variable name. And then in the compilation step, it adds in my actual variables, which I put in my server. I don't know why I did that, but that's where it is. So I take these and I essentially replace those. So I wrote a middleware component to Rework that just goes in and replaces those variables with the actual values. And that's pretty simple. And so if you come here, I can show you the output. And you'll see that there are actual background colors. And there are actual widths and all this kind of stuff. So it's real. It happens. And it's fun. And it works. And yay. So some things that DevTools is really good at is saying, hey, I know where this rule is working on my page. I can go and say, I can right-click on something and say, what styles apply to this element? But you don't actually have a lot of insight into how your Sass variables map up to things on pages. You don't have that. It's compiled to CSS before it ever gets to the browser. So we have that information. And so what I also did was I grabbed the AST stage and I flipped the AST on its head. So you can take your variables, and you can say which selectors do they apply to, and which rules work on those selectors based on that variable. So you might say if BG color ends up being black, then you would say it would output in the end output that the body HTML bracket background color colon black close bracket, right? And that would be the rule that's generated from a black BG color. And we have this data available to us as JSON. And if I change anything in our CSS file, this automatically just gets changed. It's not something I have to maintain separately. It's just completely generated from the AST of our stuff. And so I have a few things here. It says 2 next to BG color. And I can hover over it, and it says the BG color of the HTML element, which is the total wrapping element, the body, which has a margin on it, comes down to where the margin is. And then the font color of leave them alone is the same as the background color. And so we see that we actually have 2 rules where it's used. It shows up 3 times on the page, and we can actually position something over every time we see this variable. We can also come in here, grab a color picker, and change these in real time. So we can have 60 frame per second recompilation of styles because we know exactly which elements are affected by this. We don't have to go back to the server and recompile. You'll notice the text is changing at the same time as the background there. We can actually just pop into here and check. I just inject a style element with just that rule in it. And that rule says the body and the container subheader now have this new color. And it just overrides our current styles. And so that's pretty nifty. And that's information you could never get from DevTools until they have deeper integrations with this stuff. You can also do fun stuff with border radius. I like this is trippy right here. Ready for this? Oh, there's CSS for you. This is my favorite one. That's going to translate well on the slide deck. Anyways, that's actually just about all I have. Does anyone have questions?